So you're going to have a few different questions, especially in 7.7. There's also a couple in 7.6. They basically just ask you to graph. I mainly want you to think about those as transformations. So even if the directions say something else, you can still think about them as transformations. If they say like use a table or something, you don't need to use a table unless you really want to. Okay. So we're just going to use transformations. That should be faster. So this guy is an exponential function. You guys tell me, growth or decay? Growth, because we just learned that E is like 2.7 something, right? So it's definitely going to be growing. It's going to have that nice growth shape. Okay. You should be able to do these without your calculator. You can definitely check them with your calculator. On the final, you won't have it for graphs like this. Okay. What transformations have been applied? +1 goes up.
Oh, yeah.
Because it's outside. Where's the inside of this function? The inside is really right there, whether they put parentheses or not, right? The inside is the exponent. So this guy moves it up 1, so let's say up 1. And this is on the inside, so that's going to go left or right. So right by 2. Luckily, transformation rules never change. You know them. Never change. Okay. I think so. We're going to have this kind of a shape. Normally, what point did it go through? What's the y-intercept, pretty much? And a y-intercept is 1 because anything to the 0 power is 1, right? But I think that's a little bit different now because now that point, just like everything else, has gone up 1 and over by 2. So we're going to go like up 1 over by 2, about right there. So I know that that point 2, 2 is on the function. I'm not sure if it goes through that anymore. But now I can just kind of draw it. So I'm going to go like that. Make sure you put any important features on the function and try to get 2 points, right? We talked about 2 points. What's a really important feature for exponential functions? The intercept, yeah. So let's try to get that point. And then also the asymptote. What's this asymptote? It's still the same. I don't think it changed. Still 0. Oh, there is it. Good question. Well, we moved the whole graph, not just that y-intercept, up 1. So is it 0 anymore? I think I made mine go down too far. If you look at it in your calculator's graph, you'll definitely see it doesn't go down that far. So I think the asymptote was 0, and just like everything else, it gets pulled up 1. So I think that the new asymptote is going to be right here at y equals 1. There we go. That makes more sense. And now this guy is going to come down and not touch 1 instead of not touching 0. Okay? Make sure you label the asymptote a couple points. I think we need our calculator to get this point. So there's no other way. So what is that y-intercept? If we plug in 0, what do we get?
Well, we can use our calculator.
If I do that, oh, and I forgot to use this. I'll do it later. If we plug in 0, go E. You can do this in your head or not. What's 0 minus 2? If you want to put 0 minus 2 up there, you can. Press over. And there we go. So it's 1 and just a tiny bit more. Is that 3.5?
Yeah. Yes.
Thank you. Okay. There we go. Let's do number 3. Just to do something a little different. So number 3. Where is this guy? Try to get some different people involved. Rachel, can you tell me one of the transformations? I think so. Are you guys sure that that's not right, too? It depends how they wrote it. How do we know it's down to? Because it's on the outside. Now, if they had meant this was inside, they had to tell us what? They'd have had to have parentheses like that. So if you see that, you know that like the parentheses are right here, okay? That could be definitely confusing sometimes, but you guys seem like you're good. So that's outside, so yes, it's down 2, and what's this 5 do to it? It's multiplied. It's outside, so it's also vertical. It's going to be a stretch, a vertical stretch by 5. So it's just going to be stretched up a little bit. Just like our parabolas were stretched up and got narrower. So then you've got to know, okay, what's the basic shape for a logarithm? Like this, right? I think exponentials grow really fast. Remember, logarithms start out growing really slow. They're that inverse shape, that diagonal reflection. This one was growing really slow until we stretched it, and then down to, where's this go through, by the way? It still goes through x equals 1 this time, yeah? Because it's a reflection. But instead of going through 1, it's been shifted. So I think that that point, I'll draw the new point. So if this was just log of x, log base 10, right? Then I think the new one's going to be like 1, 2, all the points on it are shifted down a little bit. So I'm going to move that point down 2, and then instead of growing slow, I'm going to say, probably grows a little bit faster, something like that. I'm not exactly sure, but that's plenty good. Okay? So we've got 1 point on it. We know that point is 1, -2. If I want another point, I better just plug something in. Let's see. Let's go out here to like 3 and see where that goes. Where is this point? 3. Luckily, this is log 10, so we can use our calculator easy. So I'm going to go 5 log of 3 minus 2. Ah, what's wrong with my shape? Growing too fast still, isn't it? Maybe we should go look and compare here. See if you know the calculator well. You can definitely compare. So let's just do log of x minus 2. And then let's do 5 log of x minus 2. Make that one bold. There's log of x minus 2. See, it's growing a lot. See, my blue curve, that was mine. My blue curve was even growing too fast, wasn't it? It's too steep. This one definitely got steeper when we put the 5 on there, but mine was just scaled kind of bad. So I think my graph is still okay. It's just need to fix that. So it's kind of like this. And then it went. You guys get the point. So we had 1 and -2, and then I plugged that in. I got 3 produced 0.386. Okay, so there you go. I think it did what we expected. It's just I didn't have my code slow enough. Alrighty, let's do. See if we can do 2 more. Okay. Number 2, exponential, logarithmic. It's obviously exponential. Mr. Proctor, is that growing or decaying?
Decay.
Yes. I think you looked right here, and he said, hey, that's less than 1, so that's decay. Yeah, what's this 10 do to it? Makes it vertically stretched. A whole bunch. So it should be growing even faster, or excuse me, growing, decaying even faster. And then what's the negative do? Is it going to flip it down or flip it this way? X or on the Y? That's how you decide, right? It's on the Y. It's on the whole thing. So I think let's just start with the original picture. So I think that that's probably looking something like this. going through at 1. That's just 1/3 to the x. If I transform it, I know I've got to make it steeper, so it's got to be steeper. That's what the 10 does. And then what's this do? So steeper. I know, yeah, by the way, the new y-intercept is 10. If we plug 0 in, now we get 10. -10. Why? Because what's that negative do? We use that. It's going to flip it down. So instead of being up here, it's going to be down here at -10. Let's imagine this shape. So it would be like this, flipped down, kind of like that. I should say my asymptote is still at 0. Last one, I left off the asymptote. What was the asymptote on that last one? Go back and look at your picture we've got. It's not flat, right? Logarithms have vertical asymptote. I should have labeled it. X equals 0. So don't forget to label your asymptotes, okay guys? Alright, here's another logarithm. We'll make sure we label our asymptote on this one. This one is perhaps the most tricky. So let's just put it in our calculator and see where it says first. Yeah, I kind of see a logarithm shape. What's happened to it though? It's been flipped, right? That way. Which makes sense, because where's the negative? Negative's on the x. And it's been also shifted left or right? What's the picture say? Picture says went from like this to like this, but then it moved to the left. What the heck? -2. -2 is supposed to be... So something about order matters here. Here's the idea. If you want to clearly see something like that inside, you've got a factor. So these both share a minus. If that negative is inside, make sure you factor it. So I'm going to factor it, and then this becomes plus. So there we go. So we've got left 2, and this is a flip to the left. So that's going to go like this. Hold on just a second. There's your asymptote, -2, and it's flipped this way. Mr. Houghton, can you tell me where this goes through? What's that point? Oh, he's going to his calculator, smart. So he's plugging in 0 with his calculator, I'm guessing. Except if you plug in 0, I bet it says undefined. Because there's nothing there, is there? Very good. Did you graph it? Very nice. Okay, so he's got a handle on that graph. So pretty much I'm guessing it's -3, because normally logarithms go like 1 away from their asymptote. This is still 1 away from the asymptote over there. It's on the other side. Does that make sense? If you're going to solve this and solve this with your calculator another way, you'd have to say 0 equals the natural log and solve that equation. Let's solve it. How do I get x? Mr. Ramos, how do I get inside there? Nope. Exponentially. Yeah, unlock it. What's anything to 0? If I'm solving for xi, divide by. There it is. So much easier to just know the picture though, right? And just know that logarithms usually start 1 away from their asymptote. And now I've shifted it left by 2 and flipped it over, so it's a -3. Okay? So there you go. All right, we're done.
Why did it stop?
What's up? Oh, on the graph?
Yeah.
Erlen's saying, why did it stop? Remember, calculators suck at graphing logarithms.
So that's why.
Yeah. If that helps. If you zoom in, you'll see it keeps going. And then it goes a little more, and it goes a little more. It has trouble drawing it. You guys have a nice weekend. Make sure you work on that. If you want to start on the final stuff, it's there.
Actually.